This is the AQA, required practical, in the preparation of salts. We'll actually make copper sulfate starting with sulfuric acid and copper oxide. We'll require some sulfuric acid dilute and copper oxide. This is the black powder, and this will react to give us our copper sulfate. The reaction doesn't actually happen when the sulfuric acid is cold, so it's necessary to heat the sulfuric acid and then add the copper oxide until we've used up all the sulfuric acid. So the first stage is to warm the sulfuric acid. To do this, we've got our usual heating equipment: tripod, bench mat, gauze, Bunsen burner. Just check that this one works. I'll light it up first. Fine, that one works. We'll start with a small beaker, and we'll need about 40 cubic centimetres, 40 millilitres of the sulfuric acid. So, not quite going to use that much. Pour it in. Sufficient for my purposes today. Then it's a simple matter of warming the acid. We must warm it, but we mustn't get it to boil. Now, it's possible we could use a water bath and leave it in there until it warms up, but with a bit of care, we just heat it for a while, and just before it starts to boil, we'll take the heat away. So this session will just be heating the acid. I've been warming this acid here for approximately 2 minutes, and it's nowhere near boiling yet, but I think that it's warm enough to be able to react. So that being the case, I'll turn off the gas, remove the Bunsen burner, and now I'm ready to add the copper oxide. Now check for the safety goggles, because there's always a chance that something exciting might happen. Sprinkle a little bit of it in, and you can see it's fizzing. It's reacting. I've got a pale blue solution. That tells me it's reacting, so I'll sprinkle the rest in. The reason why we stop heating is so that it doesn't all boil over. Now I can still see that that solution is just fairly blue, there's no leftover black, so I'll add a little bit more of the copper oxide. And I'll keep on doing this until the copper oxide fails to react. Now I think I'm about that point, so I'll give it a stir with the glass rod. And I can see that the solution is mostly blue, a little hint of black unreacted. So I'll just add just a little bit more just to make sure. Good. There we go. And give it a stir to make sure it has every chance to react. Now the beaker, we've just been heating this, it can be quite hot, it can be quite warm. I'd suggest that you touch it to see it's not too hot for you to deal with. If it's not too hot to deal with, you carry on. If it's too hot to deal with, you just leave it till it cools a bit. So I'm happy with that. So a quick stir. I believe that is it. So we've got, in this beaker, we've got copper sulfate solution and unreacted copper oxide. I need to remove the unreacted copper oxide. That's the next stage. Okay, the next stage is to separate the unreacted copper oxide from the copper sulfate solution. The copper oxide is the black solid and the blue solution is copper sulfate. Now because the solid is insoluble, I'll filter it. My technique is to fold the filter paper in half and then in half again. And once I've got that, I separate one of the leaves away from the other leaves and pop that into the filter funnel. You normally use your finger to hold it in place, and then it's simply a matter of pouring the liquid into that part. Ensure none goes down the side. So in it goes, straight down the middle, get a bit of a swirl. And again. That's it. Now, despite how much you're tempted to poke anything in there to help stir it up and move it on, do not push anything into the filter paper. It's just a matter of waiting for the filtrate to drip through into the conical flask, and what we'll be left with in the filter paper will be the residue, the insoluble material. It's not really too difficult, it doesn't take too long, and I think round about now it is done. So I take the funnel away. I don't need the unreacted copper oxide, so I can discard the filter paper. And this is what I'm interested in, the blue copper sulfate solution. The next part is to separate the copper sulfate from the water, when in fact we'll separate the water away from the copper sulfate. The next stage is to separate the water from our copper sulfate to leave us with solid copper sulfate. Now, we're going to use evaporation to speed things up. We're going to use the Bunsen burner, and we will heat this beaker of cold water. Once this is warmed up enough, the heat from that will rise, the steam from that will rise, and it will heat our evaporating basin. And there's our evaporating basin where our copper sulfate solution will go. So I'll start that going. Pour that straight in now. Fine. Bunsen burner. Light it. And away it goes. I'm going to use a strong blue flame to speed things up. Once the water is starting to boil, I'll let it go for 3-4 minutes, and that will be enough to evaporate most of the water. After that stage, we'll then take the copper sulfate solution and we'll pour it into a crystallizing dish where we can leave it for the crystals to fall over 2 or 3 days. Once the water in the beaker begins to boil, it condenses on the bottom of the evaporating basin, and the heat energy is transferred to the liquid in the evaporating basin. After a while, the water in there will begin to evaporate, and that's why we call it an evaporating basin. Right, after a while, the copper sulfate solution will begin to evaporate. The vapor you see here is because of the boiling water, but the heat energy is being transferred to our copper sulfate solution. It's better to do this than to place the evaporating basin directly on the gauze. In that case, there'll be a lot of spitting and it'll be very violent. This is a more controlled way of doing it. We'll just need it to evaporate. Now it's boiling for about another 2 or 3 minutes, and then we'll go to the next stage. Right, the water's been boiling vigorously now for about 5 minutes, and if I look in the evaporating basin, I can see that the copper sulfate solution is bubbling. That means that that's fairly warm, so that's evaporating. I'm looking to see if they're starting to get crystals around the edge where the liquid is. Can't see any yet.
So I'm going to give it another couple of minutes, and then I'm going to stop heating, and then we'll go to the final stage. So we'll turn the Bunsen off, and before we can handle this, we're obviously going to have to wait for it to cool. There's no point in rushing because it's very, very, very hot, and there's a chances that you'll get burned, you'll drop the apparatus, and then you'll get burned. So it's just a case of just waiting for 3 to 5 minutes for it to cool down sufficiently for you to be able to touch it so that you can move it and use it. There are no hard and fast rules as to how cool that must be before you can touch it. It all depends on you. You leave it until you are happy that you can touch it and safely move it to where you want to. Now the beaker will be hotter. Just a bit. I can manage that. These metal parts will be too hot even for me to touch, so I'll leave those there for a while, and whilst I move away and get the rest of the apparatus. Okay. Once the heating apparatus has cooled sufficiently for you to be able to move it around and get rid of the stuff you don't need anymore, you'll be left with your evaporating basin with a small amount of concentrated copper sulfate solution. What you've done when you've evaporated is you have driven off a lot of the water, and what you're left is a more concentrated solution. You could use a crystallizing dish. We're using this plastic dish as that, and it's a simple matter of just pouring that in there, and we can leave it somewhere warm, doesn't have to be by the window, and over time the rest of the water will evaporate, and what we'll be left with will be copper sulfate crystals. That's it. And finally, this is what it's about. These are the actual copper sulfate crystals, and it's a simple matter of leaving them for the rest of the water to evaporate, and you're left with solid, blue, hard, dry copper sulfate crystals. They do contain some water crystallization, and that's why they are blue. If we were to heat them strongly on a flame, we could drive off that water, and what we'll be left with will be anhydrous copper sulfate. But this is what we make from this reaction.